Alright, in this tutorial we're going to be looking over finding the arc length or the sector area. So before we look at questions, we just need to write down what these two formulae are. So if you're trying to find the arc length, then you use theta, which is the angle over 360, multiplied by, and if you're finding an arc length, it's a section of the circumference of the circle. We know that the circumference of the circle is pi times the diameter. So for the arc length, we do theta over 360, the angle over 360, multiplied by pi times the diameter. And then for the sector area, you follow the same process in that you have the angle, theta over 360, but this time you multiply by the area of a circle, the area of the whole circle. So it's a section of the whole circle, and that's pi r squared. So you need to know these for the exam. These aren't given in the formula sheet. So arc length, theta over 360 times pi times diameter, and sector area, theta over 360 times pi r squared. I'm just doing them both in one tutorial so that we can use both of these by substituting in and working out what the question's asking. So I'm going to do 4 examples. The first 2 are more straightforward, then two past paper questions after that. One of them which is non-calculator, so the last one will be non-calculator. Okay, we've got this one here. Calculate the area of the sector shown in the diagram below, given that its radius is 6.8 centimetres. So, okay, calculate the area of the sector. We're pretty much told what we're having to use here. So using sector area. So I'd write this down every time. So for question number 1, sector area, I'm just going to write down SA this time. Sector area equals theta over 360 times, and its area, pi r squared. Now we can just substitute in. Sector area is, and we use the angle in that sector. We've actually been given the angle in the sector, so it's fairly straightforward. Substituting in 135 instead of theta over 360 multiplied by pi multiplied by r. And it's telling us, it's not written on the diagram, but it tells us, given that the radius is 6.8 centimetres, so times 6.8 squared. Okay, so your sector area. You then use your calculator. So we're doing 135 over 360 multiplied by pi times 6.8. I'm pressing all the wrong buttons, times 6.8 squared equals, if you get that, you just press your 1 to take it to decimal. So you've got 54.475 ... And then we're just going to round that to 54.5. We were in centimetres, so squared centimetres as its area. And that's you for the first question. All right, we're going to do another one. This one is actually a past paper question. I think it's from the 2017 paper, maybe even 2018. So it says, the diagram below shows a sector of a circle, centre C. The radius of the circle is 7.4 centimetres. Calculate the length of the major arc, AB. So major arc just means, because A to B, you could go this short way, and that would be the minor arc, but it's not actually part of it. This one we're looking for, the major arc, is the large one that's all the way around. So it's told us calculate the length of the major arc AB. Length of the arc, we're going to use arc length equals theta over 360 multiplied by pi d this time, because it's a section of the circumference. Arc length equals, we've been given the reflex at this large angle here, which matches the one of the major arcs. So we can just put in 320 over 360 times pi times, and just be careful here, the radius of the circle is 7.4, so we need to use the diameter, so just always check that you're actually using the right one. Diameter is double the radius, so multiplied by 14.8. Right, time to use your calculator. So 320 over 360 multiplied by shift pi times 14.8. This time we have 41.329 ... And then we round that to 41.3 3, and just centimetres because it's a length this time. So the arc length, 41.3 centimetres. Right, that's two fairly straightforward questions. If you've got one of these, it might come up. If it comes up like this, it will put one of the first few questions in the past paper. Like here, this was question number 2. Next one we're going to look at, it's got a few other things to think about. So the Yummy Ice Cream Co. uses this logo here. It's made up from an isosceles triangle and a sector of an area, and a sector of a circle as shown in the diagram. The equal sides of the triangle are 6 centimetres. The radius of the sector is 3.3 centimetres. Calculate the perimeter of the logo. So if you're asking for the perimeter, that is the arc length plus these two bits here. So that's the length the whole way around. So just be careful, even if those lines right there and you were asked for the perimeter of the sector, you would find the length of the arc and then add the length that you need to. Here the logo goes length of the arc plus these two. That would go around the whole logo, this one here. Okay, so first of all, we're going to need the arc length. That's really what we're being tested on here. So arc length, we know, is theta over 360 multiplied by pi times diameter, because it's part of the length. Here we need to be careful, because this 100 degrees, that's actually this part here. We need our angle to match the arc we're trying to find. So we need this one here that's shaded in black. That's a full circle if we go around the whole way. So we know if that 100 degrees, this one will be 360 minus 100 degrees. So this one here is 260 degrees. So just make sure you're actually using the angle that matches the arc length you're trying to find. So you've got 260 over 360 multiplied by pi multiplied by the diameter. So what have we been given here? The radius of the sector is 3.3. So again, we just need to make sure we actually use the diameter. So multiplied by 6.6 because we have to double the radius. That's you pretty much done all the work for the arc length. It's now just putting it in your calculator. 260 over 360 multiplied by pi multiplied by 6.6. So we've got 14.974 ... We're going to round that to, actually that would round up to 15.0, so it's just 15 centimetres for that. And we're not done there because that is the arc length. So the perimeter of the whole logo is going to be the arc length, which is 15, plus 6 plus 6, so plus 12 altogether. So the perimeter of the logo is 27 centimetres. And that's you for that one. Last one we're going to do is a non-calculator one. This is a past paper question. Can't remember exactly which paper this comes from. So the diagram shows a sector of a circle, centre C. The radius of the circle is 20 centimetres and angle ACB is 45 degrees. Calculate the area of the sector. So because this is non-calculator, we're just being asked to use pi as 3.14 because we don't have a calculator to use pi to more decimal places. So calculate the area of the sector. Sector area, it's exactly the same as before, is theta over 360 multiplied, we're in area, so pi r squared. So substituting in what we've got now, 45 is our angle here, so 45 over 360 multiplied by, we know that instead of pi we're going to write 3.14 this time. Only do this if it's a non-calculator paper. If it's a calculator paper, then use your pi button on the calculator. Multiplied by radius squared. Radius is 20, so 20 squared. So now we have this calculation to do without a calculator. So 45 degrees we know is half the size of a right angle. So if a right angle is 90 degrees, that's 45 degrees. We know our right angle is a quarter of the circle, so this is going to be an eighth. If you weren't too sure of that, you can always do it by just simplifying as much as you can each time. You can see you can divide the top and the bottom by 5, so I'd start with that. Dividing by 5, you'd end up with 9 over 72. Then actually you can see you could divide both of them by 9. Divide the top by 9 is 1, 72 divided by 9 is 8. So you could get to the fraction just by simplifying. So 1/8 times 3.14 times 20 squared will be 400. So we're getting closer. I think here I would then do the 3.14 times 400. To make it easier, I'm just going to do this in red so you can see. 3.14, multiply it by the 100 first. So you've got 314. And then multiply it by the 4. So for the 400, we've multiplied it by the 100 first, then the 4. 4 times 4 is 16. Carry 1 over. 4 times 1, 4 plus the 1 is 5. And then 4 times 3, 1,256. So last little bit, we now know that we're doing 1/8 times 1,256. So then we just want to do that division. 1, 2, 5, 6. Finding an 8th is the same as dividing by 8. So 8 doesn't go into 1, carry over. 8 goes into 12. 1 time remainder 4. 8 goes into 45. 5 times remainder 5. Sorry, and 8 goes into 56. Sorry about that. 8 goes into 56 7 times. Rather than starting again, I'm just going to carry through my cough. 157 squared centimetres. And that's you.